All right, list operations is the first topic we are discussing today. So given the following code segment, how can you best describe its behavior? Result equals 0 for each n in list. If n mod 2 equals 0, result equals result plus n. So we are looking at all of our elements, finding if the current element is even, we will add its value to our result. So we are finding the sum of all of the even numbers in our list. So for each loop, it's going to grab every single element and add that element to our total. Given the following code segment, how can you best describe its behavior? You can assume a number is a positive integer and is prime of x, returns true if x is prime, like you might expect. List is empty. I equals 1. Repeat number times. If is prime of I, append to our list I. I equals I plus 1. Display the length of the list. So does this code display the total number of prime numbers between 1 and number? Display the list of all the prime numbers between 1 and number? Display the sum of all the prime numbers between 1 and number? Or error? Well, if we're displaying the length, select draw. If we're displaying the length, we're not going to see the whole list. We're not going to see the sum. So neither of those. And I don't see any errors in this program. It seems like it would all work correctly. So it's going to display the total number of primes starting at 1, going up until number. Clear? There we go. Given the following mystery procedure, how can you best describe the result it returns? Mystery, you get a list and a target. Length equals length of list. I equals 1. Repeat length times. If list at index I equals target, remove list at index I. Otherwise, I equals I plus 1. And then we return the list. So are we returning the list without the first instance of a given target? Return the list without any instance of the given target. Returns the list where each instance of the given target is replaced by the index, or returning the number of times the target appears in the list. So since we're removing things, it's going to be probably one of these two. We're not returning, we're not replacing anything, and we're not counting the number of times this has happened. So are we going to remove only the first instance, or we're going to remove every instance here based on the code that we see? Okay. After we do our first remove, are we stopping the loop at all? We're not exiting the loop. So I think if we don't exit the loop, we're going to keep on looping. And if we see another instance of target, we're going to remove it again. So we're going to remove all instances of the given target. And the reason that we don't increase I when we remove something is, let's say I have the list 2, 3, 4, 2, 3. And I want to remove the number 2. If my index is here, index is 1, and I remove that element, this should all slide down. And I want to still check that the element that is slid into place still whether or not it is the value I'm trying to remove. So if I had two 2s in a row, if I moved I in both scenarios, it would not check always if there was a duplicate. If I had a 2 and then a 2, if we increase I after we do a removal, we're not going to check that value that is slid into the place we took out. So we only want to increase I when we didn't do the removal. This is why we have the algorithm looking like this. All right, question 4. Given the following code segment, how can you best describe its behavior? I equals 1 for each x in the list. Remove list at index I. Random equals random from 1 to the length of the list. Insert list random x. I equals I plus 1. So are we replacing everything in the list with random numbers? Are we shuffling the order of the numbers in the list by removing them and inserting them back in a random place? Removing all of the numbers in the list and inserting random numbers in random places in the list? Or are we causing an error by trying to access an element at an index greater than the length of the list? So let's look at this. Let's do a little example to make this a little clearer. Say our list is 2, 3, 4. So for each element in our list, first we're going to get 2. I starts at 1, so we're going to remove 2. This is all going to slide downward. So x is going to equal 2 right now. We're going to generate a random number between 1 and the length of our list. So we're going to pick a random value between 1 and 2. And we're going to insert into our list random, insert into our list at index random the value of x. So let's say I'm picking between 1 and 2 here. I pick 2. We're going to insert 2, the value 2, at index 2. So this is going to slide upward. We're going to insert a 2 so that it has index number 2. And then I increases to 1, or I increases to 2. X would then once again be 2 because we inserted it at that same index. We're going to take it out and then pick a random index and insert it. I becomes 3. Take that out. Grab a random value and insert it. So is this going to, I feel like this is going to shuffle the order by taking them out and inserting them back in a random place. Seems like the what we're doing here. So let's check. Yes, we are pulling random numbers out and inserting them back in at a random location. And given the following mystery procedure, how can you describe the value it returns? You can assume list is a list of numbers that has at least a length of 1. X and Y are both initialized to list at index 1. For each n in list, if n is greater than x, x equals n. If n is less than y, y is equal to n. Return y minus x. So are we going to, so if we look at this, if ever we see a value bigger than our variable x, x is going to equal n. X is probably just going to be a maximum value. If we ever see a value smaller than y, we reassign y. Y is going to be the minimum value in our list. So when we return min minus max, we're not returning the highest or lowest numbers. Probably not going to return 0. We're going to be returning the range of values in the list, the It's the difference between the largest and smallest values. If you want to rewatch a certain problem's explanation, the recording will be on the lesson plan for the day on learningvcs.net. Good question. So I will post these recordings to the lesson plan each day. All right, so there is that question. These all make sense? Any queries on these ones? All right. Quiz 2, bits. How many possible values can you represent with 2 binary digits? 4. We have 2 to the power of the number of digits. It's going to give us 4 values. Which of the following scenarios cannot be represented by a Boolean variable? Whether a light switch is on or off, whether an exam is complete or incomplete, the value of an ASCII character, or whether a letter is a capital letter or not. One of these things is not like the others. The only one that has more than 2 options. That's the ASCII character one, because there's lots of different ASCII characters. So each of these other ones only has 2 potential states, on or off, complete or incomplete, capital or not capital. What is the minimum number of bits you would need to represent a number on a 0 to 10 scale? So if we're using binary, what is the smallest number of bits to represent a number between 0 and 10? So here at 4. So if I have 1 bit, I can represent 2 values. If I have 2 bits, I can represent 4 values. 2 to the 4 is 16, right? So if I have 16 total values, I can absolutely represent anywhere between 0 and 10. 2 to the 10, that's way bigger. That's like 512 or something. That's way more characters than we need, or way more numbers than we need. So the minimum number is going to be 4, because the value in between 3 bits gives us 8 possible slots. We can't represent 0 through 10 with only 8 bits, or 8 numbers, 3 bits. What is the greatest value you can represent using 8 bits? So our powers are 1, 2, 4, 8, 16, 32, 64, 128, and that's 1, 2, 3, 4, 5, 6, 7, 8. Wait, what? 1, 2, 3, 4, 5, 6, 7. Yes, 64, 128. So what is the sum of all of these values? 1 plus 2 plus 4 plus 8 plus 10 plus 72, 64, 128. Well, it's going to be 1 less than the next power of 2, which is 256. So I can't represent 256 using those 8 bits. So it's going to be 1 value less. The biggest value is 255. Now we can represent 256 total numbers because we include 0 here, but the largest value we can represent is 255. And our last question, how many values can you represent with 3 binary digits? I answered this earlier. We can do 8. 2 to the 3rd power gives us 8. All right. Question 1 in the randoms section. X equals random 1, 5. What are the chances that X has the value of an even number? So what numbers can we get from this? 1, 2, 3, 4, and 5. Now, how many of these are even? 2 out of 5 are even. What percentage is that? That's 40%. So we have a 40% chance of an even value here. You are writing a program to simulate a coin toss. What line of code could be used to replace so that there is a 50-50 chance of your, so there, wow, could be used to replace so that there is a 50-50 chances of your program printing heads or tails. That's stellar grammar there. If missing condition, display heads, else display tails. So we want our random 1, 2. That's going to equal either 1 or 2. So it's never going to be greater than 2. It's never going to be less than 1. It's never going to equal 0. The only one that's possible is random 1, 2 to equal 1. What are the possible values you think that could result from this line of code? You're talking about this one. Random 1, 5 gives us 1, 2, 3, 4, or 5 as possible results. You are writing a program to play a dice game using a fair die with 6 sides. What is a proper call to the random function that would simulate rolling the die and saving the value in a variable? You want a random number between 1 and 6 inclusive. I feel like we've discussed at this point multiple times that that second number is included. So we want roll equals random between 1 and 6. So our first parameter is the smaller number, or the small bound. Second number is the large bound, inclusive on both. And question number 5, you have seen the following program below. What is the difference between the largest and smallest value that could get printed to the screen? So the smallest value would be when both are 1. 1 times 1. That equals 1. The largest values are 2 and 3. 2 times 3 is equal to 6. The difference between those is 5. So subtract 1 from the other. That is the difference. So there are our recap questions today. That all clear? Sensical? Cool. Well, I'm only assigning one quiz today called robot questions. And there are 12 questions on the robot questions quiz. So we should have a good amount of time in class to work on this. We'll talk about these robot questions next time. So I will stop our recording.